solving inequalities becomes important, especially when we start talking about ranges of numbers and ranges of values that a function can have, which we will talk about somewhat in high school calculus. Significantly, if you go on to take university level calculus, this will come in more and more often. The good news is that some inequalities you have seen, mostly not since about grade 9 math. There are some other inequalities that will get thrown at you that do complicate things a little bit, but we do have strategies to deal with them. So the first one would be a typical type of inequality that you would have seen in grade 9, very similar to an equation, but we need to solve this, and to solve this means isolating x, getting it by itself. So you can choose to isolate the x's on the left or on the right. It doesn't actually matter in this one, but I'm going to choose to isolate the x's on the left just to illustrate one thing that could cause you a hiccup. So to do that, I'm going to have to subtract the 6x. When I do that, 3x minus 6x combining the like terms would be negative 3x. Minus 1 that we have is less than or equal to 2. Continuing on, trying to isolate the x, I'm going to add 1 to both sides, which gives me negative 3x is less than or equal to 3. And last step would be to divide both sides by negative 3. And that dividing by a negative. So because we divided by a negative specifically, the inequality is going to flip directions. What I mean is that we'll still do the calculation. Left side is going to be x, right side 3 divided by negative 3 is negative 1. But the inequality, and it's because we divided by a negative specifically, is going to flip the other way around. Now, I did say express the answer in interval notation. This is inequality notation. So we need to look at this. X is greater than or equal to negative 1, meaning the range of numbers that we have starts at negative 1 and continues on to infinity. As we know, brackets for infinity always round, and the bracket on negative 1 will be square because it has the equal to line with the inequality. Now, I could turn this into a double inequality and put two inequality signs in the same problem. We have to do the same operations. None of that changes, except now instead of two sides of an inequality, a left side and a right side, now we technically have three sides. We have a left, a right, and now a middle. So the math doesn't change. We still need to isolate the x, and we specifically need to isolate it in the middle, which will become clear for the reason why once we get to the answer. So first step is the 2 in the 2 minus 5x needs to move. So we'll subtract 2, and from all three sides. Doing the calculation on the left, we get negative 10, which is less than or equal to, we have negative 5x left over in the middle. Less than or equal to, on the right, we end up with 15. Last step to isolate the x is to divide by negative 5 on, again, all three sides. Do the calculation on the left, that works out to 2. In the middle, that works out to x. And on the right, that works out to negative 3. And again, because we divided by specifically a negative, the inequalities will flip direction. And just because we have two of them doesn't change that. They will both flip direction. Again, I've asked for an interval. So now we have two numbers in this inequality, but putting 2 and then -3 doesn't make a whole lot of sense, because when we do inequalities, we put things in order. So we would flip this around and put -3, 2. And both of these will get closed brackets because both of those inequalities have equal to lines. One other thing that could happen is we could have an inequality with rational expressions, basically fractions. Specifically where the x is in the denominator. As I said before on this example, we need to make sure that we isolate the x in the middle. So to keep it in the middle, the way we accomplish that is by taking the reciprocal of all three sides. Taking the reciprocal functions the same way as dividing by a negative, so we have to change the direction of the inequalities if we take the reciprocal. How do we know that we have to do that? Well, this example here is exactly why, because the variable, the x, is in the bottom. Now, in order to take the reciprocal, it's helpful to have all of these sides in terms of fractions. The middle is, but the left and right are not. And as we know, we can always put a 1 under something. Commonly done in cross multiplying. We're not exactly doing that here, but it is going to be useful to put a 1 under that when we take the reciprocal, which literally means we're just going to flip top for bottom. So on the left, -5 over 1 reciprocates into 1 over -5. We flip the direction of the inequality. 10 over 1 minus x flips into 1 minus x over 10. The other inequality also flips, and we end up with 1 over -3. This does leave us with a bunch of fractions which do complicate things, so easiest thing we can do is get rid of them first of all. We have a -5, a 10, and a -3 as denominators. We should try to find a common denominator between all three of them, just to make the fraction simplification easier. 30 is about the cleanest common denominator. It's the lowest common denominator. So I'm going to take every single side, multiply it by 30. So we do the calculations. I'm going to shortcut a little bit. On the left side, -1 times 30 would be -30 on the top over 5, because technically that 30 is over 1. I'm not going to straight ahead multiply on the middle side, because that's going to defeat the purpose, and we're just going to have to factor again. What I am going to do is I'm going to reduce as much as possible the 30 that I multiplied by with the 10 that was there. We should be able to reduce it completely to a whole number if we picked our common denominator correctly, which we did, so that'll be a 3. So what is technically left is 1 minus x times 3. And on the right, again, we'll do 1 times 30, which is 30, over the negative 3. Simplifying things out, on the left here, negative 30 divided by 5 is negative 6. In the middle, this 3 needs to get distributed into the 1 and the x, so that will end up being 3 minus 3x. And on the right, 30 divided by negative 3 is negative 10. So now we're left with a very similar situation to the last example. We need to get the x isolated in the middle, so I'm going to take and subtract 3 from all these sides. I'm going to shift up to the top of the page to do that. On the left, negative 6 minus 3 is negative 9. In the middle, we're left over with negative 3x. And on the right, that works out to negative 13. Last step to isolate the x, we need to divide all 3 of those sides by negative 3. On the left, that works out to 3. Again, we divided by a negative, so we'll flip the inequalities. Again, yes, we can do it twice in the same question. The middle, we have x, and on the right, we're just going to leave that as a fraction. We're not going to change it to a decimal. The negatives will cancel, so that's going to be 13 over 3. And again, interval notation, we have the numbers in order this time, so 3 and 13 over 3. Both will get round brackets because there are no equal to lines with those inequalities. Now, the last type of inequality that I could throw at you is a quadratic inequality. Quadratics are things that have an x squared term. In order to solve these, we have to do something called a sign analysis. This came up a few times in pre-calculus 20, but it hasn't since then. Sign analyses will be a common theme throughout parts of calculus. So they will come back again more than once. The process is not all that difficult. We do need to take this quadratic and factor it. We need to find 2 numbers that will both multiply to negative 7 and also add to negative 6. Those would be negative 7 and 1. So this would factor into x minus 7, and x plus 1 is greater than or equal to 0. Once this has been factored, we're going to leave the inequality for a moment, and the sign analysis is where we take those factors, one of them being x minus 7, the other one being x plus 1, and we're going to place those on a number line. What we put on the number line is what value of x would I substitute into x minus 7 to make that turn into 0. It happens to be 7. So I'm going to jot a 7 on the number line, and I know that when I put a 7 in for that x, that this x minus 7 will work out to 0. At that point, I've divided up that specific factor into two sides, the left of 7 and the right of 7. So now I need to ask myself, well, if I picked a number on the left of 7, let's say I picked 5, and I substitute a 5 into x minus 7, what would I get? So I would have 5 minus 7, which is negative 2. And I don't care specifically that it's negative 2, I only care that it's a negative number. And in fact, no matter what number I picked on the left of 7, I would get a negative out. So I'm going to fill up that space with negatives because those are the types of numbers that I would get. Ask myself the same question on the other side of 7. Let's say I picked 10 to put in. Put in 10 for x, that works out to 10 minus 7, which is 3. And 3 is a positive number. So no matter what number I picked on the right of 7, I would end up turning into a positive. Repeat the same process with the x plus 1. What number would you have to substitute in for x to turn x plus 1 into 0? That happens to be negative 1. Negative 1 would make that turn into 0. Again, two sides. Pick a number on the left of negative 1. Let's say negative 6. And substitute that negative 6 in and see what happens. So we would end up with negative 6 plus 1, which is negative 5. Not caring that it's specifically negative 5, only caring that it's negative. Any number on the left of negative 1 would be a negative when you substitute it in there. Picking a number on the right side, I already have 5 or 7 or 10 that I could choose. I'm going to choose 5. Substitute that in for x into x plus 1 gives you 5 plus 1, which is 6. And 6 is a positive number. And no matter what number I picked on the right of negative 1, I would get positives. So those are the pieces of the sign analysis. Now we need to put it all together. So going back to how it was in the inequality, it was x minus 7 times x plus 1. In order to figure out the sign of x minus 7 times x plus 1, we're going to take the signs of the individual factors and multiply them together. We always start by lining up the zeros, and right here at negative 1, we have a negative number times 0. Anything times 0 is 0. Lining up again at 7, we have 0 times a positive number, and again 0 times anything, still 0. This now has 3 sections, a left, a middle, and the right. On the left here, we have a negative times a negative. And negative times a negative is a positive. In the middle, we have a negative times a positive. That is a negative. And on the right, we have a positive times a positive, which is a positive. This is almost the end. We now need to loop back to the inequality to tell us which out of the positives and negatives actually matter to us. So the inequality, the sign says, well, x minus 7 times x minus 1 is greater than 0. Greater than 0 is actually a useless term to us because the sign analysis tells us positives and negatives. Greater than 0 is also known as positive. So this whole process of the sign analysis, we've actually been trying to find where is this function positive. At the bottom here, we found that it's positive all the way in this area and all the way in this area. Putting that in interval notation, this area here on the left would go all the way from negative infinity until negative 1. Brackets, round on the infinity, and square on the 1 because the inequality, back up here, had the equal to line with it. Now that's not the only area where this is positive. It's also positive in that second one that I underlined. That second area goes all the way starting at 7, ending at infinity. Brackets on that, the infinity gets a round one as it always does. The 7 gets a square one again because of the same equal to line with the inequality. And we need to put a mathematical symbol in between these two intervals to show that it's this area or that area. Both of them apply. And that symbol mathematically is that, again, it looks like a U with no tail. It is the mathematical symbol for the word or. Similar question here. Again, beginning of the process doesn't change. We need to factor this. We need two numbers that will both multiply to 8 and add to 6. Those would be 4 and 2. So we have x plus 4, x plus 2 is less than 0. We're going to take those two individual factors, the x plus 4 and the x plus 2. We're going to place them on a number line. We're going to ask ourselves in x plus 4, what number would I substitute in for x to turn x plus 4 into 0? Well, that number is negative 4. I'm going to pick a number to the left of negative 4. Let's go with negative 5. If I substitute that in to x plus 4, I get negative 5 plus 4, which is negative 1, which is a negative number, and anything on the left side would be negative. Pick a number on the right side. I'm going to go extreme and go with 7 this time. Plug in a 7 into x plus 4. We get 7 plus 4, which is 11, which is a positive number. And no matter what number I would have picked on the right of negative 4, I would have got a positive. Repeat the process with x plus 2. What number would you substitute in for x to turn that into 0? Well, that would be negative 2. Pick a number on the left. I've already got negative 5 in yellow. I'm just going to keep going with it. Put in negative 5 into x plus 2. You get negative 5 plus 2, which is negative 3. And any number to the left of negative 2 would have been a negative, just like that one was. Pick a number to the right of negative 2. I already have 7 in yellow. I'll keep going with it. Put 7 into x plus 2. You get 7 plus 2, which is 9. And that's a positive number. Any number on the right would have been positive. Putting it all together, in the inequality, it was x plus 4 times x plus 2. So putting it together, that's what it will be. With the signs, we line up the zeros, this one here, and this one here. On the left one, we have 0 times a negative, which is 0. On the right one, we have a positive times 0, which is 0. And again, we get 3 sides. Left side is a negative times a negative. Those are positives. Middle, a little bit smaller this time, but still there. Positive times a negative is a negative. And the right side, positive times positive, is positive. Going back to the inequality, it's the sign that matters for the next step. That sign means we are looking for where x plus 4 times x plus 2 is less than 0, which for us, since we care about things defined as positive or negative, less than 0 would be better useful to us as saying negative. Looking to the sign analysis, this is negative right here in the middle this time. So unlike last time where we had 2 sections that we needed to concern ourselves with, now we only have 1. So that 1 section is bordered on the low side by -4 and on the high side by -2. Those are the 2 numbers that define our interval. And they are both going to get rounded brackets because that inequality had no equal to line with it.